All right, for our final lesson on transformations, we are going to be talking about dilations. This one is a little bit different than the rest because it's actually going to create a similar figure. You're not going to have congruency anymore because dilation is the enlargement or reduction of the original figure. So as you see from this picture, if you've ever been to the eye doctor and you've had your pupils dilated, if you think about what happens to them, it means they enlarge your pupils so they can see inside your eyeball. That's why you have to wear sunglasses when you leave, because you got to the sun and you feel like you're blind. So a dilation, we experience that with our eyeballs, and then also when women are having babies, they have to be dilated in order to give birth. So you can think about that one a little bit on your own. Okay, so the way that these ones work, if we are dilating, we use what's called a scale factor, and the scale factor is going to tell us if our new image is going to be larger or smaller than the original. So if we look at the frogs, this frog right here is the original. This little guy right here was dilated with a scale factor of 1/2. So basically means it's going to be 1/2 the original size. So anything less than 1 is going to take your original shape and shrink it down. This one has a scale factor of 1. So you're pretty much taking the size of the original frog and multiplying it by 1. Which means they're the same size, even though this picture is a little deceiving. This looks slightly bigger, but scale factor 1, no change. The second guy over here, he's got a scale factor of 2, which means this original frog is being multiplied by twice the size to get your jumbo toad right there. So this is kind of how it works. You have your X and Y coordinates, so you have to get your coordinates before you can do anything with these. And then you're going to take whatever your scale factor is and you're going to multiply it by each of the coordinates. So, for instance, if we look down here at this example, we have A, B, and C. Okay, we want to do a scale factor of 2. So I'm going to write these over here kind of big. 12, 9. B is 12, 6. And C is 18, 9. Okay, so if we're dilating by a scale factor of 2, we're going to take each of these coordinates and multiply them by 2. So we have A prime, which is going to become 24, 18. B prime is going to become 24 and 12, because we're taking each of those and multiplying by 2. And C prime is going to become 36 and 18. Okay? And in the same aspect, if we were going to use a scale factor of 1/3, we're going to multiply each of these coordinates by 1/3, which basically means divide by 3. So we're going to call this A prime prime, because this is our second one from the original. So that 12, 9 from the original up here, we're going to divide each of those by 3. So we get 4, 3. And then B becomes 4, 2. And C becomes 6, 3. So that's kind of how it works. So if we see a real example on a coordinate plane, we have to first say what the coordinates are. So I is 4, 0. J is at 2, -4. And K is -2 and 4. Now, one of the nice things about this is coordinates are positive and negative, but your scale factor is always positive. So basically, if your coordinate was positive before, your new one's going to be positive. If it was negative before, it's going to be negative as the new one. So it makes it a little bit easier. Oh, these are the originals. Okay, so this is going to be dilated by a scale factor of 2. So we're going to take all of these and we're going to multiply them by 2. So I prime, let me keep the colors here, is going to be 8, 0. J prime will become 4, -8. Now, how am I getting these numbers? I'm taking these original coordinates and multiplying them by 2. And K prime is going to be -2 times 2 is -4, and 4 times 2 is 8. So now we have our coordinates. We're going to go over to the coordinate plane and we're going to plot these guys. So I prime is now here at 8, 0. I meant for that to be purple. J prime is going to be at 4 -8. So down here, sorry, I need to label these as I go. And K prime is going to be at -4.8. So all the way up here. So when we connect our dots, you can see that our shape still looks the same, but it has grown and it is now twice the size. So that's a scale factor of 2. Now we're going to do one in the opposite. We have IJK, and we're going to dilate this with a scale factor of 1/4. So the first thing we need is our original coordinates. So I, J, and K. So I is at 4, 0. J is at 2, -4. And K is at -2, 4. Alright, so our scale factor is 1/4. So we're going to multiply this by 1/4, which also means divide them all by 4. Okay, so I prime, we're going to take this 4 and divide it by 4. So I prime is going to become 1, and then 0 divided by 4 is 0. And change my colors here. J prime, 2, -4, so 2 divided by 4, it's actually going to give us 0.5. -4 divided by 4 is -1. And K, -2 is going to give us again -0.5. And 4 divided by 4 is 1. So there's our new coordinates. So this shrank down to a little itty bitty. So there's I prime. J prime is at 0.5, which is going to be halfway between 0 and 1. And -1, so right there. Oh, not half its size, I meant a quarter of its size. So that's J prime. And K prime is at -0.5 and 1. So like right there. It's hard to get this exact. Alright, so this is our little itty bitty shape right there. It shrank down. It is now 1/4 of the original size. Alright, so that is how we do dilations.